version complex numbers, just for you to kind of get that out of the way, because you got to, you know, understand some basic things about complex numbers, okay? So first of all, I is defined to be the square root of -1. Okay, I think this comes from, I think it was René Descartes, and Descartes was the mathematician, philosopher who came up with the coordinate system, who first had the idea, let's just kind of use I to represent a square root of a negative number and see what happens. Okay, it turns out that imaginary numbers are all over the place, and they're certainly in polynomials and what we're going to see there, but they show up in parts of physics and electronics and stuff like that. Those of you who are going into engineering, you'll kind of see what I'm talking about, particularly if you study electronics. So we're going to do powers of I. So first of all, I to the first is just I. I want to just show you kind of the pattern on this and how this works. If you do I to the second, that's defined to be -1. The reason is, remember, I is the square root of -1. So if you square a radical, the radical comes off. So really, by definition, I is just the square root of -1. I to the second is -1. And then the rest of these things can be built out of those two things. Okay, so it goes like this. When you do I to the third, you just do I to the second times I. Okay, you can break it up into I to the second times I to the first. Well, I to the second is -1. So what you would have is -1 times I is -I. Okay, so I to the third is -I, just based on what we got with the first two results there. I to the fourth, now there's more than one way to break these up, but you could say I squared times I squared. Okay, what's I squared? I squared is -1. So if you take -1 times -1, you would get +1. So that's how you can reason out what the powers of I are. I just want to show you kind of what happens on these things as we continue to get into the bigger exponents. So I'm going to do this row here the same way. I to the fifth, a good easy way to do that would be to break it down into I to the fourth times I to the first. I to the fourth is 1, so that would be 1 times I, so you're back to I again, okay, like that, all right? If you did I to the sixth, one way to do that would be I to the fourth times I to the second. Well, I to the fourth is 1, I to the second is -1, so that turns out to be -1. Okay, do you see what's happening? It starts repeating itself, okay? Every 4, it's going to repeat itself. So I to the seventh, you could go I to the fourth times I to the third. I to the fourth is 1. I to the third is -I. So 1 times -I is -I. So it would go like that. And then the idea with the last one, I to the eighth, you could break it up into I to the fourth times I to the fourth, which is 1 times 1, so it's equal to 1. So basically your powers of 8, they go on over and over again like that. They always work that way, okay? I want to show you one thing on your calculator. If you don't know this, is kind of nice. If you look down at your decimal, at the bottom row, you should see the letter I coming out in a different color. So basically, most of these calculators will work with I. So if you want to try one of these, let's just try like I to the eighth. You could go second decimal, get I to come out, and then you could raise that to the 8th power, and it gives you the 1, okay, like that. So you can do powers, and sometimes they'll turn out kind of weird. So if you do I to the, like the 37th power or something like that, and that just gives you I, okay? So you can do those powers of I on there, but there are times when they turn out kind of funny depending on your calculator, all right? So that's the idea, is what powers of I are. They just are either I, -1, -I, or 1, okay? And what I want to point out to you is, notice that you have a plus minus I, and then you also have a plus minus 1. So these things they come in pairs like that. One's positive, one's negative. So that's how those things go, okay? All right. Any question about what I just did there? Okay. Okay, now let's talk a little bit about a complex number then. Complex numbers are going to have the form a plus bi A and B are real numbers. Okay, so for example, if you had 3 plus 4i, we usually call 3 is the real part of the complex number, and then the 4i is the imaginary part because it's got the I in it. So that's what complex numbers always look like, is a plus bi. They can be a plus bi or a minus bi. So I want to show you a couple of things on this. There's a few things that I want that you're going to review a little bit in your homework. So I want you to write down this example first of all. Let's just say you have 3 plus 4i. The conjugate just means that it's the same thing, but you change that sign to 3 minus 4i. Okay, so I want to show you what happens when you multiply a complex number by its conjugate. Okay, and if you look at that, does that look like FOIL? That's what it is. When you multiply complex numbers, it's just distributive property, so it's like FOIL. So if you did this, first term would be 3 times 3 would be 9. Outside term would be negative 12i. Inside term would be plus 12i. And then the last term would be minus 16i to the second. Okay, so that's what happens. And what will happen when you multiply by a conjugate is those middle terms will cross out. Then you end up with 9. Okay, so let me write this over here. So you have 9 minus 16. But what is I squared? That's negative 1. Okay, I squared is negative 1, so you can replace that I squared with negative 1. So you end up getting this. You end up getting 9 plus 16, so it's equal to 25. So when you multiply a complex number by its conjugate, you end up getting a real number. Okay, like that. So the i's kind of cross out. They work their way out of the problem. So it'll always work that way when you do that then. Okay, that's the idea. Okay, all right, any question about that? Okay. So in general, what I want to look at is, this is the fundamental theorem of algebra. I want to do a couple more things and we'll take a break here in a little bit. Okay, so every polynomial function of degree greater than or equal to 1 will have at least one complex 0. Okay, so everything is going to have at least one complex 0. All right. Okay, so let's see. Let's work a little bit on the complex conjugates theorem here, which is pretty simple. And the idea is that it's basically this. Okay, if a plus bi is a 0, then the conjugate is also a 0. Then a minus bi is also a 0. Okay, so that's what the complex conjugate theorem says. Okay, so anytime that you have a polynomial, the complex zeros come in pairs. Okay, I always have a plus minus. Okay, the reason why for that is because of the quadratic formula. I mean, that's one way to think about this. So whenever you have the quadratic formula, you have that plus or minus, right? And that plus or minus, anytime you solve an equation quadratic with a quadratic formula, they're going to come in pairs. Now, it's possible that you could have the same answer twice, but still they come in pairs, okay, because that plus minus, that's the idea, okay? All right, so let's just do these things right here. This is real simple. So if your polynomial has a degree of 4, what is the maximum number of zeros that you could have? 4, okay? We already kind of learned that. You can't have more than 4, okay? So notice that I've given you 2 of the zeros, okay? I've given you, one of the zeros is 8 minus 5i. So what's another 0? 8 plus 5i. Remember, they come in pairs, okay? So that's what that says. I also gave you a 0 of 2i. So what's the other one? Negative 2i, okay? So see, those are your 4 zeros. If you know 8 minus 5i, then its conjugate is also a 0 like that. That's the idea, okay? Okay, next one, degree 5. So what's the maximum number of zeros? That's 5, okay? So let's see, I've given you 3 zeros. You got to tell me what the other 2 are. So what are the other 2? Negative I, negative 2i. Okay, remember that these come in pairs, so that's negative I, negative 2i. Now, sometimes I'll see students want to give me negative 2. That's a real number. Those things don't come in pairs like that. It's the complex numbers, the I part, that comes in pairs. Okay, so that would be your 5 zeros then. Okay, right, and then the next one, you got a degree of 6. So that means the maximum number of zeros is 6. And let's see, I've given you what? 1, 2, 3, 4. So you got to give me the other 2 zeros. What are the other 2 zeros? 2 minus I. What else? Negative 1 plus I. Right. Okay. So the complex conjugate theorem just says that these things come in pairs. So you would also have 2 minus I, and then you would have negative 1 plus I like that. Okay. So that's the idea. All right, that's real simple. That's complex conjugates theorem. All right, so I'm going to do one more thing and then we'll take a break. I want to go ahead and do the, if I give you zeros, forming the polynomial and kind of getting that out of the way. Does everybody understand what I just did? Okay, all right. Okay, because you got to use this a little bit on this next idea here. So what we're going to do is look at forming a polynomial if you're given zeros. Now this is just kind of explaining how the factored form goes, which we've talked about. It's always x minus whatever the 0 is. And then this is the fundamental theorem of algebra that says, or this is a consequence of the fundamental theorem, if you have an odd degree, you have to have at least 1 0. Okay? So here's the reason for this. All right, let's see if you guys understand this or not. Okay, what does the graph of an odd degree polynomial look like? What did you learn? There's 2 possibilities. It's either this or it's this. Does that have to cross the x-axis? If it goes like that, it has to cross the x-axis, right? So what happens is, if you have an odd degree, you got to cross somewhere, okay, regardless of which thing it is. So it has to have at least 1 0. Now, it may cross the x-axis more than once, but it has to have at least 1. What if you had an even degree? What is an even degree? What does its graph look like? That or that? Does that have to cross? No, because it could be all shifted up like that. So if you had an even degree, you might have something like that. So you would have no real zeros. Now, you would have complex zeros on that. You're definitely going to have that, but you don't have real zeros unless those things cross the x-axis. That's what's meant by that. Okay. Okay, let's do these 2 problems here, and then we'll take a break. So we're going to actually just make a polynomial out of this then. Okay, so I've given you, it's a 3rd degree polynomial. I've given you 2 of the zeros. All right. So what is the other 0? 1 minus I. Good. Okay. So now we have our 3 zeros. All right. Now we're going to make a polynomial out of this, and we're going to multiply this out and everything. Okay. So we are going to put this in a multiplied form. So these problems can be a little bit of work sometimes. So it's going to go like this. We're going to put together our factors. And remember, the factors always have the structure x minus something. Okay, so we've got our 3 zeros. I gave you 2. That's all I had to do. So what we're going to have here is we're going to have x minus minus 6. Then we're going to have x minus 1 plus I. And then we're going to have x minus 1 minus I. And we're going to multiply all this stuff out, okay, in just a minute when we do this. Okay, so I'm going to write this out. Clean it up a little bit. This is really x plus 6. Okay, so that's a factor. Then the next one would be x minus 1 minus I. And then the next one would be x minus 1 plus I like that. Okay, now that's how that would be the factored form of that polynomial. Well, we're going to multiply it out. Okay, and this can be a little bit of work. Okay, it's not hard, but it can be a little bit of work. So the way I'm going to do this is I'm just going to bring down the x plus 6. And then we're going to put these 2 together right there. We're going to multiply that out. Okay? So we got to do all this multiplication like this, all right? I'm going to do this kind of at the side where I can take up some room. You don't need to write it down again, but just so I can take up a little bit of room on this. So what we're doing on this is multiplying this out. Okay, so that first term is x times x, so that's x to the second. Okay, then I take the x times negative 1. So if I take x times negative 1, that's negative x. Okay, then I take the x times I. Okay, and that's going to give me a plus xi like that. Okay, and I'm just going to kind of start over again, and then I'm going to do the negative 1 now. Okay, so you're just doing the distributive property 3 times. So now I do negative 1 times x, which is negative x again. Then I do negative 1 times negative 1, which is positive 1. Then I do negative 1 times I, which is negative I. Now we're probably going to have some stuff canceling out on this when we do this, okay? So I got that. Now I got to start over again, but I got to do the I part. Okay, so it goes like this. Okay, if I do this, I've got negative I times x, which is negative ix. Then I've got negative I times negative 1, which is plus I. And then I have negative I times I, which is negative I squared, like that. Okay, so I mean, that's 9 multiplications. And it can get a little messy, and you got to watch signs and everything. So I'm going to see if anything canceled out. I suspect some things canceled out are going to cancel out on this if I did everything right. Okay, so let's see what happens. Okay, here it looks like the x's cross out. Okay, it looks like the xi's cross out. What's that? Oh, yes. Thank you. Let me bypass that. Okay, yeah, the x's don't cross out. Thank you. Okay, so the xi's do. That's good. The i's do. And that's it, right? Okay. All right, so what we have is we have x plus 6. Then we have x squared minus 2x there. Okay, now look at this part right here. I'm left with a 1 and a negative I squared. What are you going to do with that I squared? What is I squared? Negative 1, right? Okay, so you got to be careful about that part right there. So that's really going to be 1 plus 1, so that's plus 2. Okay, so we got that. Okay, so it's kind of messy. It's not hard, but it's messy, and it's easy to make a mistake. You saw what I did a minute ago. All right, now I got to multiply it out again, and then I'm done, and then I'll show you kind of how we can check our answer on the calculator then. Okay, so now we got to start all over again and multiply out again. Okay, so we're going to take x times x to the second is x to the third. X times negative 2x is negative 2x squared. X times 2 is plus 2x. It's not as hard this time because we don't have the i's to worry about. Then we have 6x squared. And then 6 times negative 2x is negative 12x. And then 6 times 2 is plus 12. Okay? So like terms, you have some of those. So we'd have x cubed plus 4x squared. 2 minus 12 is minus 10x plus 12. So that would be the polynomial that has those 3 zeros. Okay, that's a mess. Okay, I only signed like a couple of these on the homework. It's good for you to do this. It's a good algebra exercise. So what I want to do next here is I'm going to go ahead and let's check the answer on this. So if you want to put this in your calculator, I'll show you kind of how you can tell this is right. So, and I hope it is because it's so easy to mess up on these. So we have x to the third, and then plus 4x to the second. And let's see, minus 10x. And plus 12. And we'll just do that in the standard window. And we'll see if this is right. I'll show you a couple of things you can do. So I'm just going to go zoom 6, standard window. All you got to really do is trace out your zeros. Now I want to show you this. If you look at my graph, how many times does it look like my graph crosses the x-axis? That's important. 1. How many real zeros do we have? 1, right? Okay, so the only real 0 we have is -6. You can tell it crosses at -6. So if you trace at -6, well, that's giving you y equals 0. So that one checks out visually on that then. Now you can also, you can try this. This doesn't work on all calculators, but you can try this. Let's trace one of the complex numbers. So you can go trace, then try like 1 plus I. If you put 1 plus and then the I, you go second decimal. I can't remember if it works on this calculator or not. No, it doesn't. I think on some of them it does, but it's not on mine. But you can, I mean, there's another way you could do this. I mean, you could, and I'm not going to take the time to do this, but if you actually on your calculator put in 1 plus I to the third plus 4 times 1 plus I squared minus 10 times 1 plus I plus 12, it would all be 0. So, I mean, technically, you could plug in 1 plus I and do it that way and it'll work. Okay, did anybody try to trace that out on their calculator with the 1 plus I? I don't think it works on, it seems like it doesn't trace out complex numbers. I can't remember on that. But you could do it the other way. You could just everywhere you see an X, plug in 1 plus I. Okay? All right. Any questions about what I just did? Okay? All right. Let's go ahead and let's take a break. And while we're on break, I got some of you didn't pick your test up. So if you didn't get your test last week, you need to come up and grab your test. But I'm going to do one more example of this. Even though it's a 4th degree, I kind of designed this so it's a little easier to work out. All right, so to begin with this one. Okay, it's a 4th degree polynomial. All right, I've given you 2 zeros. Tell me what the other 2 zeros are. Yeah, negative 2i and positive 4i, right? Okay, complex conjugates theorem. Okay, so we're going to set this up like this then. So again, it's always, you got 4 factors. I like to just kind of build the framework. It's always x minus something. And that will give that a function name like f of x like that. And you just plug stuff in. So you're going to plug in the 4 zeros that we have. Some of them are going to change signs on us. So let's see, I gave you 2i. We also have negative 2i. Now let's see, you were given negative 4i. And then the complex conjugate theorem says we're going to have 4i, like that. Okay? Now you don't have to write this step. You can just do this in your head. So your factors are x plus 2i, x minus 2i. And then you would have, I'm going to write this way. It doesn't matter what order, x plus 4i, x minus 4i. So you can just jump immediately to that right there. You don't have to write that intermediate step. I just want to show you it's x minus a number. Okay, now the way we're going to put this together is like this. We're going to pair this up the smart way. So you're going to FOIL those 2 pairs. Okay, don't put together the 2 and 4i. I mean, it'd work that way, but it's a lot harder. So we're going to take a little shortcut on this. So when we put together what I've got in yellow, so you can do this in your head. You would just have x squared minus 4i to the second. Okay, because what you need to understand is when you multiply a conjugate, what happens to the inner and outer anyway? They cancel out, don't they? So that would be 2xi minus 2xi. So you can jump right into there. When you do that, you won't have to write all 4 steps from FOIL. Same thing happens on the next one. You would have x squared. Again, the inner and outer are going to cancel out, so you'd have minus 16i squared like that. Okay? So this one's not going to be too hard to do. Okay? Every time that you see an I squared is negative 1. Okay? So this is going to be x squared minus 4 times negative 1, and you can do this step in your head if you want to, and then x squared minus 16 times negative 1 like that. All right, so what we'd end up having is x squared plus 4, and then x squared plus 16. Okay, that's just kind of some standard FOIL. Now we're going to FOIL it out one more time to get our polynomial like that. Everybody with me okay so far? Okay, so you got to use complex conjugates theorem. When I squared pops up, that's negative 1. Now go ahead and FOIL it one more time. So the first term you'd have x squared times x squared is x to the 4th. Outside term would be plus 16x to the second. Inside term is plus 4x to the second. And then last term, 4 times 16 is plus 64. So you would end up with x to the fourth plus 20x squared plus 64. Okay, like that. That would be the multiplied out answer to that polynomial. Okay? Now, a couple of things that I want to see if you understand on this now. Okay, it's a fourth degree, so the graph's going to go like this, right? Okay? Let me ask you this question. Without going to my graphing calculator, is this ever going to cross the x-axis? No. How come? Because you have complex zeros. You don't have real zeros. That's why. Okay? So that's what would happen on them. While we were on break, I was showing you how you can check the answer to the last problem. So it won't trace, the complex numbers won't trace, but you can put in like that 1 plus I. That was the last problem. I just plugged in to that and it gave 0. Okay? So like if you're doing a quiz or something and you want to make sure you're right, if you're not sure about whether you're right, it doesn't take very long to use the I feature of your calculator to check those out. And you don't have to bother 1 minus I because you know it's going to work. Okay? There's a theorem that tells you that then. Okay? So that's the idea. That one you could check on your calculator. You would probably roughly find this. I can tell you what you would find. You would have a y-intercept of 0.64, and the graph would probably kind of do something like that. But it would never cross the x-axis. That's what I want you to know. All right, everybody with me okay? Okay. Okay, so that's pretty much what I'm going to do on that. I don't assign too many problems on that on your homework, just a little bit because it's good practice to kind of see how the i's and stuff multiply out. Okay, I think the rest of the section, mostly what we're going to do is find zeros of polynomials, all right? And the way typically that I do this is the way I do this on a test, is I usually give you a 0, okay? So this one I've given this polynomial. I went ahead and just did the graph, you know, outside of class this morning. So I've given you basically this 0 right here. So what we're going to do to start with is it's a fourth degree, so that means we're going to have a maximum of 4 zeros. We can't have more than 4, okay? So we're going to find the other zeros. Let's go ahead and start. We have no choice but to start by dividing synthetically with negative 2i. Notice you have missing terms. So you have 1x to the fourth. You don't have an x to the third, so you put a 0. You have a negative 21x squared. You don't have an x, so you put a 0. Then you have a constant of 100 like that. So make sure that you have placeholders for everything. 4, 3, 2, 1, and then constant like that. Okay? All right. So what's the remainder going to be on this problem? Hopefully 0, I hope, okay? If not, then I've messed up on this problem. Okay, so let's go ahead and do this and see what we get. Okay, so you bring down the 1. Negative 2i times 1 is negative 2i. Add the column. That's negative 2i. There's some stuff you may have to do a little scratch work at the side. So if I do negative 2i times negative 2i, and you can do this all in your head, I don't care. This would be 4i squared. What's 4i squared? That's negative 4, right? Okay, so that will give you negative 4 like that. When I squared pops up, remember that becomes negative 1. Okay, add the column, that's negative 25. Multiply, negative 2 times negative 25 is 50i, and it's positive. Add the column, that's 50i. Okay, and then again, what you're doing on this is you're doing negative 2i times 50i, which is negative 100i squared. So what is that? That's positive 100. Okay? Again, you can do all that in your head if you want to. So anyway, we got a remainder of 0. That's what we expected to happen. Okay? All right, so we got that, and you have to start the problem that way. Now what you do, we did one of these in the last section, is you take the result and you have to divide another 0 into this result. So that result is 1, negative 2i, negative 25, and then 50i like that. Now, I only gave you one 0. Do you know another 0?
Yes.
What is it?
X plus 2i.
2i. Don't look at my graph. Okay, 2i. Let's pretend like the graph's not there. Okay, you can tell what the other two zeros are there. But 2i, okay, by the complex conjugates theorem. Let's go that way. Okay, all right. So far, one of our remaining zeros is 2i. We know that because of the complex conjugates theorem. So what we have to do now is we have to synthetically divide again. Okay, so we bring down the 1. 2i times 1 is 2i. That crosses out, makes 0, which is great. 2i times 0 is 0. Add the column, that's negative 25. Multiply, you would get negative 50i. So you have a remainder of 0. See, that's what we expected to happen on those. Okay, but you have to carry out the details to get down to this point here. Okay, now remember, this was a 4th degree polynomial. So it kind of goes like this. This is the remainder. That's a constant term. This is x to the first. That's x to the second. Okay, so that really is a quadratic equation that we're left with. So if you just write what you're left with, you have x squared plus 0x minus 25, or x squared minus 25. Now you got to set that to 0 and then solve. Okay, which is easy. On this one, you could either factor or you could do the square root property on this. So let's just do the square root property on this, or you can do this in your head. It's easy enough to do. So you would have x squared is 25, square root both sides. So you would have x equals plus minus 5. Okay, so your other two zeros are 5 and negative 5. And you can tell by the graph that I got up here that that's right. So what I want you guys to know from this then is it crossed the x-axis twice, right? How come? What made it cross twice? What do you know about the zeros? 2 real zeros, right? The real zeros are 5 and negative. The other ones are imaginary, so that does not mean that the other two don't cross. Does that make sense? You only cross the x-axis where you have real zeros. Okay, so that graph right there, you want to make that connection when you're learning that then. Okay? All right, any question on that? Okay, so you've done all this synthetic division on these sections all the time. Okay, let's look at, I'm going to look at some kind of different situations. There's several different things that can happen on these problems. Okay, so let's see. This one I've given you, it's a 3rd degree. So that means you're going to have a maximum of 3 zeros. I've given you the first 0 is 1 plus I. Okay, now we have to divide this like this. So we're going to divide 1 plus I synthetically into the polynomial. So we have 1, 7. You have to kind of spread this out a little bit too, because you're going to have some complex numbers you have to deal with then. Okay, so we have 1, 7, negative 16, and then 18 like that. All right. So we're just going to have to deal with the 1 plus I. All right, and it works out exactly the same way. You know we're going to get a remainder of 0, because I told you, as long as I type this out right, it's going to be a 0. So bring down the 1, multiply. 1 times 1 plus I is 1 plus I. Okay, like that. Okay, 7 plus 1 is 8. So that's 8 plus I. You're just kind of like adding like terms. Okay? Now what you can do over here is stuff like this you got to kind of do at the side. I'll show you a couple of ways you can do this too. So I'm just going to, on scratch paper, I'm just going to multiply that out by FOIL. So that's going to be 8 plus I plus 8I plus I to the second. Okay? That's going to give 8 plus 9I, and then again the I squared becomes negative 1. So you end up getting, it looks like 7 plus 9I. Okay? So you do that. Now, if you're in a crunch on your homework, I don't have a problem. You just want to know how to do what I just did. But you could also just really quickly go like 1 plus I, like this, just to verify. You can use your calculator on this if you want to. And then 8 plus I. And you can use your technology to do that. You want to know how to do this both ways, though. By the time I put all these buttons in, I probably would have been done anyway. So there we are, 7 plus 9i, okay? So you can use your calculator to FOIL and multiply out two complex numbers. Okay, so that means what we'll put here is we'll record the 7 plus 9i like that. Okay, add the column. That would be negative 9 plus 9i like that. Okay, now you can do the next one the same way if you want to. You could go 1 plus I, and then you could go negative 9 plus 9i, and I'm pretty sure you'll get a negative 18. Okay, all right, I knew it. I could feel it. Okay, because I knew what was going to happen on our remainder anyway. All right, everybody with me there? Okay, use your calculator too if you want to kind of speed that up a little bit, because you're going to have to do the FOIL a lot. Okay, now what you got to do is you got to divide again. All right, so the complex conjugate theorem tells us that another 0 is 1 minus I. So we have to take the 1 minus I, and you have to divide that into this result. So the result is 1, 8 plus I, negative 9 plus 9i, like that. Okay, and you have to do that, otherwise you aren't going to get that other 0. Okay, so let's see how this one works out. Okay, so we'll bring down the 1, multiply 1 times 1 minus I is 1 minus I, which is nice. 8 plus 1 is 9. The i's cross out, so you have that, so that's kind of nice. Then you're just, when you're doing 9 times 1 minus I, that's like a distributive property. So that's 9 minus 9i. Okay, so again, we got a remainder of 0 like we expected to. Okay, so we got that. Now, we got one more 0 to get. It's a third degree polynomial, so we're going to have one more 0. So again, what you have is, this is the remainder, this is a constant term, and then this is x to the first. So that result is x plus 9. All right, what do you do with that? You set it to 0, then you solve. So what's the other 0? Negative 9. Good. Okay, so you solve that, you get x equals negative 9. Okay, you can tell graphically that that is right. Okay, so what happens on this odd polynomial, it crossed the x-axis once because we had one real 0. And every time you have an odd degree polynomial, it has to have at least one real 0. It has to cross the x-axis somewhere in order to have that shape. Does that make sense? Okay, it's got to cross somewhere, not the even degree polynomials, but that. All right, everybody follow what I'm doing on that? Any questions? Okay, so you got to do the synthetic division. This is kind of the way I test over this. I usually just give you a 0, then you find the rest of them that way. Okay, so you don't have to graph and find a 0 on that. Okay, so let's see. I'm going to do this last page. I'm going to do one other situation here. Just kind of show you what happened. I'm trying to just kind of get through all the possibilities on here. Okay, so this one I'm giving you a 0 of negative 4. You can tell by the graph that I put up here that you can tell it crosses at negative 4. So we're going to go ahead and do the synthetic division by negative 4. So the polynomial, you have 1, negative 2, negative 11, and 52. So we should have a remainder of 0. Okay, so let's go ahead and do that and verify that then. So bring down the 1. Negative 4 times 1 is negative 4. Add the column, that's negative 6. Multiply, that's 24. Add, that's 13. Negative 4 times 13 is negative 52. Okay, so that's what we have. So we know that we have 3 zeros. One of them is negative 4. Let me ask this question. Is positive 4 another 0? Good, okay. Now that's the real number, okay? So those don't come in pairs. So what we got to do is just figure out what we're left with. So remember, that's a remainder. That's the constant. That's x to the first. That's x to the second. So what you have a quadratic equation, x squared minus 6x plus 13, and you're going to set that 0. Okay. Now, look at my graph that I have on the calculator. Is this quadratic equation going to have real solutions or complex solutions? Complex. How come? Only crossed one time, right? It crossed at -4. Since it didn't cross again, that means these are going to generate complex solutions from the quadratic formula. So what you have to do is you have to get these by doing the quadratic formula. Okay, and you don't need to write down the quadratic formula. I like to just write it down, as I'm teaching this. So we want to go ahead and plug that in and simplify. So we'll have -6 for b, plus or minus the square root of -6 squared, and then 4 times a, which is 1, times c, which is 13, and all over 2 times a like that, okay? And what will happen on this, you'll have 6 plus or minus. Under the radical, it looks like you have 36 minus 52. So see, it's a negative number under the radical, so it is complex. Okay, so if I do that, is that 16, I think? Yeah, so that would be 6 plus or minus square root of -16 over 2. Okay, so a little background issue here. When you're doing a square root of a negative number, really you can kind of do it this way. You just do this in your head, but you're really writing this as square root of -1 times square root of 16. Square root of -1 is I, square root of 16 is 4, so that is 4i. Okay, so you would just write this as 6 plus or minus 4i all over 2. You don't simplify square root of 16 because it's already a perfect square, so its square root is 4, but it's 4i. Then you can split this up. You can do this part in your head. So that would give 3 plus minus 2i. Okay, so your other two zeros, and they come in pairs because of the quadratic formula. You would have 3 plus 2i, and you would also have 3 minus 2i. Okay, so that's how you would find those two zeros, and you have to do that by hand. Your calculator won't find those two zeros for you because they're complex. All right, any questions about what I did? Okay, we've been doing synthetic division like mad today. That's kind of, you do this all through these sections. So I'm going to show you one other thing, and this one is solving an equation. Everything that we did before, I just said find the zeros. Now I'm solving an equation, so it's essentially the same thing. You got a polynomial equation set equal to 0, so we're going to do the same thing. All right, now the P over Q list, I'm just going to do this one more time, but what you would do in practice is you would just get your calculator out and try to find a 0. If it's a 4th degree polynomial, you want to try to find 2 zeros on your calculator. Okay, so again with this one, what you would have is P is that number. Okay, so I'm just going to put plus minus, and you can abbreviate it this way, so it would just be 1 and 54. I kind of go outside in when I do these. And then it would be 2 and 27. And then I think it would be 3 and 18. You can use your calculator to help you. 3 times 18 is 54. Well, let's see, 4 and 5 don't work, but 6 and 9 also work like that. So that P is just all of the factors of 54. Okay? Q is all of the factors of 1. So that would just be plus minus 1. So what's the P over Q list? It's just the P list. So what you could do on this is just write this as, just write the P list then. So that would just be plus minus 1, 2, 3, 6, 9, 18, 27, and 54. You could do the bounds theorem if you wanted to, but there is no point in doing that. It looks like from my graphing calculator, the zeros are -3 and -2. So notice that they're in that list. They don't have to be, but they are in this case. Okay, this is going to have 4 zeros because it's a 4th degree polynomial. Okay? All right, so take your pick as to which one you want to divide by. I'm going to start with -2. And I'll divide that polynomial. So I have 1, 5, and then 15, 45, and 54. Now we're solving an equation, so we got to find all the zeros. You got to get at least 2 by your graphing calculator, though. Okay, so we'd bring down the 1, multiply, that's -2. Add the column, that's 3. Multiply, -6. Add the column, multiply, negative 18. Add the column, that's what? 27, thank you, okay. Negative 2 times 27 is negative 54. It's okay, we have a 0 of negative 2. That would be one of the solutions of that equation then, okay. All right, now what you got to do is take the other 0, which is negative 3, and then you got to divide that into the result. So that result is 13927. So you got to do it again. And the graphing calculator seems to show that that's a 0. So, and you have to do this because you won't get the other two solutions if you don't go through and do this. So that would be a 1, negative 3, 0, 0, 9, negative 27, and 0 like that. Okay, so what happens then is, again, this is a constant. That's x to the first. That's x to the second. So this equation is x to the second plus 0x plus 9, or in other words, that's x squared plus 9 equals 0. Okay, is that equation going to give you complex number solutions or real solutions? Complex. You can tell this thing is, and it only crosses 2 times. So that means the other 2 zeros have to be complex. This one you don't want to factor. You want to use square root property. So you would have x squared equals negative 9. Square root both sides. So you'd have plus minus 3i. So the square root of 9 is 3, so that would be imaginary numbers. So what you would have for your answers is you would have x minus 2, you'd have negative 2 and negative 3 from the calculator. Then you have 3i and negative 3i like that. Okay, and that's how that goes, all right? Okay, one other thing I want to have you do on this problem too is, if I wanted you to write this in the factored form, just do this in your head on the factored form. You would have x minus negative 2 times x minus negative 3 times x minus 3i, and then x minus negative 3i. You can do that in your head, change the sign. So if you factored this, you would have x plus 2, x plus 3, x minus 3i, and x plus 3i like that. So that's how you would factor that polynomial, okay? And that's how you generate those zeros of negative 2, negative 3, 3i, and negative 3i. Okay, that's how that goes. Okay, so what do you think? Yeah.
So did you notice start with negative 2 by just using your graph?
Absolutely, yeah.
Okay, so for these problems, you'd be able to use your graph.
Yeah, like in a test, what I generally do is give you a 0.
Okay.
On homework, sometimes they'll give you a 0 on homework. If they don't give you a 0, just get your graphing calculator out and find one. Okay. Okay, you got to start somehow, and that's what you're going to need to do. Okay. We used to, when I was a college algebra student, we had to just do the P over Q and just try stuff until we found one. So yeah, it does. And you'd wad up your paper, and we don't want to do that crap anymore. We just want to use our technology to help us. Okay, any other questions about anything on this?